Hello students. In the last session we were dealing with heat and temperature. Today we are going to deal with ideal gas equation and absolute temperature. So what is meant by ideal gas? Ideal gas means a perfect gas. So let us see the properties of ideal gas and how we take the equation for the ideal gas. A thermometer that uses any gas will give the same reading regardless of the gas it is used, because thermometer reading does not depend on the nature of the gas. Thermometer reading does not depend on the nature of gas. It depends only on the temperature. So the variables that describe the behavior of the gases are the number one, the quantity of gas, which means mass. Number two, the pressure. And number three, the volume. So mass, pressure, volume. And when we heat the gas, the temperature will also rise. So pressure, volume, temperature and quantity of mass. So those are the four things: pressure, volume, temperature and quantity of mass. So I just express it as PVT, and for mass I can express M. Now always when we take T, that T is degree Celsius plus 273.15. That means always in the ideal gas equations and the ideal gas calculations, you have to take the temperature in Kelvin. The gases which have low density obey certain laws, and these gases, the gases which obey these laws are called ideal gas. So the first law is Boyle's law, and Boyle's law tells that when pressure increases, the volume of the gas decreases. That means pressure is inversely proportional to volume. When pressure of the gas increases, the volume decreases. Pressure is inversely proportional to volume. So P proportional to 1 by V, or I can say PV is equal to constant. This happens at constant temperature only. Now the next thing is Charles' law. Charles' law tells that when the pressure of the gas is kept constant, when the pressure of the gas is kept constant, volume is directly proportional to absolute temperature. So I can say V proportional to T or V by T is equal to constant. V proportional to T or V by T is equal to constant. That is Charles' law. So if we combine these two laws, I can write like this: PV proportional to RT, PV proportional to T, or PV is equal to RT. This is the ideal gas equation for 1 mole of gas. For any amount of gas, we can say PV is equal to mu RT, where mu is the number of moles. We can also use PV is equal to nRT or PV is equal to mu RT, where mu is the number of moles. This value R is called universal gas constant, and its value is 8.31 joule per mole per Kelvin. That is the value of R, universal gas constant. So the gases which obey the equation PV is equal to nRT or PV is equal to mu RT, such kind of gases are called ideal gases. Now in a constant volume gas thermometer, the temperature varies with respect to pressure. That means when pressure is increased, the temperature also increase. So the temperature changes linearly with increase in pressure. So you can see the graph as a straight line. Okay. Now, what is meant by absolute zero? So I was telling about Charles' law. I told volume directly proportional to absolute temperature. So I am instead of simply using the word temperature, I am using absolute temperature. So what is that? Absolute temperature means temperature in Kelvin. Okay, absolute temperature means temperature in Kelvin. So what is absolute zero? It is the temperature, it is the lowest possible temperature that we can achieve where the complete molecular motion stops. At that time, the pressure of the gas will be zero, the volume of the gas will also be zero. So it is the temperature at which the complete molecular motion stops. So the pressure of the gas and the volume of the gas becomes zero. Such temperature is called absolute zero. So that is the lowest attainable temperature. So it is the minimum absolute temperature of an ideal gas. Now just see this graph. Here you can see I have plotted a graph between temperature and pressure. When temperature decreases, the pressure also will decrease. So pressure decreases, and at 0 degree the pressure is this much, and again I am reducing the temperature to the negative value, and you can see that at one particular temperature called negative 273.15 degrees Celsius. Negative 273.15 degrees Celsius. At that particular temperature, you can see the pressure of the gas is becoming zero. The pressure is touching the 0 point. The pressure of the gas is becoming zero. At that time, volume also becomes zero. This is why I am saying that this is the lowest attainable temperature. What happens if I increase the temperature beyond a limit? What happens if I decrease the temperature below this? The volume of the gas becomes negative, which is not possible. Okay, so gases cannot achieve negative volume. That is why this is considered as the lowest attainable temperature. Okay, so the absolute zero is negative 273.15 degrees Celsius. That is considered as 0 Kelvin. So temperature in Kelvin is written as capital T. Temperature in Kelvin can be found by the equation Tc plus 273.15, where Tc is the temperature in degrees Celsius. Tc plus 273.15. Okay. If we open the freezer compartment of our fridge, what all things you will see there? You can see ice, you will see some droplets of water. At the same time, you will be seeing the vapor, and that vapor is very cold vapor. So water becomes vapor when it heats up, that you know, but in the freezer it is freezing cold until you can see the vapors. Why? How come that happened? There is a certain temperature and certain pressure where all the three states of the liquid coincides. There is a certain temperature and for a certain pressure at which all the three states of the matter coincide. That means solid, liquid and gas. All three states will coincide. That temperature and pressure is called triple point of what? Triple point. So you can give the heading triple point. It is the state at which the three phases of water, that is ice, liquid and vapor coincide. That means they exist in equilibrium. So you can note down the value of pressure for the water. Okay, for water, for the triple point, the pressure is 0.46 centimeter of mercury, and temperature is 0.01 degrees Celsius. So please note down those values. That is the triple point of water. So it is the pressure and temperature at which all the three states of the water coincide. Not only water is having triple points, other liquids also will have triple point. Carbon dioxide is having triple point. Gases are having triple point. So this triple point is unique for each substance. Okay, so by understanding the triple point, we can understand the substance. So triple point is unique for each substance. Why we always study about the triple point of water and the triple point of other substance? Because we know the melting point and boiling point will change with pressure, with the other atmospheric conditions. And we have studied in lower classes, when we go to higher altitude, the cooking is difficult because at high altitude the pressure is very less. So water boils at low temperature. When you go to Mount Everest and try to boil the water may boil at 70 degrees Celsius instead of 100 degrees Celsius. Similarly, in pressure cooker, you know normal cooking and pressure cooking. Which is faster? Pressure cooker cooks faster. Why it is like that? We are closing the lid of this pressure cooker and we are not allowing the steam to go out initially. So the steam pressure keeps on increasing, and when pressure increases, the boiling point also increases. So the water will not boil at 100 degrees Celsius. The water in pressure cooker boils at 121 degrees Celsius. So the food inside that will get that much temperature. So the food cooks faster. That is why the pressure cooker cooks faster. So what we studied just now is, at high altitude pressure decreases, boiling point also decreases. And when we increase the pressure, the boiling point also increases. And I have given the example, pressure cooker cooks faster and at high altitudes cooking is difficult. So what I want to mention about these two examples are, the boiling point will change with the change in pressure. So you can't understand a substance by its boiling point and melting point. Boiling point and melting point will change with such change in pressure. If we increase the pressure, the ice will melt. Even see, you know, if I freeze the water to 0 degree, it will become ice. Imagine I am bringing it to -4 degree. So it will be ice. Now take a knife and then press on the ice hardly. So press it hard. Then you can see, even though the temperature is 4 degrees Celsius, the point where we are pressing, the ice will start melting. It is because we are increasing the pressure, and at the time the pressure is increased, the melting point is decreasing. That is why ice melts at even -4 degrees Celsius. So our point of discussion is, the melting point and boiling point will change with the change in pressure, but this triple point is unique. It will not change. That is why we are studying the triple point of all the substance. Okay, so please note down these points that I have explained just now. What is triple point, why it is unique, and about the boiling point. Boiling point increases with increase in pressure, and about the melting point, and I told pressure cooker cooks faster. So all those examples what I have told, you just make a note of all those. Okay, so that's all about this session. Thank you.